Hello everyone, welcome to our lesson, and I am Precious. In this lesson we're going to consider the concept of modular arithmetics, and so through it we're going to look at how to evaluate given integers in different moduli, and then we will see how to carry out basic operations of addition, subtraction, multiplication, and division. We will see how to solve equations involving modular arithmetics, and these are keywords that we're going to see in this lesson. And so in modular arithmetics, we write integers, which are whole numbers, both positive and negative, by rotating them in number cycles. And the numbers we rotate them around is called the modulus or the modulo, which is actually abbreviated as this. So what this means is that, for instance, I want to write 5 in mod 2. This is how we write it. Okay, so what it means is that I'm going to be rotating 5 in twos, and whatever I have left will be my solution. So if I have something like 0 here and this is 1, so I begin 1, 2, 3, 4, and then 5. So I ended at 1. Therefore, 5 mod 2 is actually equal to 1. And then what are other ways to do this without doing this rotation? So we say that all you need to do is to divide that integer by the modulus. That means the mod you're taking it to. And when you do that, whatever is your remainder is what you record as your modulus. Another way to do this is just to express the integer as a product of the quotient and the modulus, and then whatever is the remainder, you add it. So in any of these cases, you are interested in the remainder. Of course, you can see that here. If I divide 5 by 2, I am going to get 2 remainder 1. So let's look at, and now you see how to read this like I did here is m modulo n is equal to r being the remainder. So look at some instances here. 13 mod 6 is actually equal to 1 because the remainder, when you do this division, is 1. And then again, you can see the same 13 in mod 5 is now equal to 3 because the remainder here will be 3. And now look at another way to write this. I can say 13 is equal to 1 mod 6. Right, so how do we evaluate integers like what we just did now? I already said it. Look at these two examples. Evaluate 11 in mod 4 and 78 in mod 9. So all you need to do is now divide this 11 by 4. You are going to get 2 remainder 3. And that's why I expressed it this way, which is 2 times 4 plus 3. Of course, will give you back your 11. Since we are only interested in the remainder, therefore our 11 mod 4 is equal to 3. And so look at the next example. If you divide this by 9, you will get 8. And so 8 times 9 is 72. And so our remainder is 6. And that's going to give us the solution here as 6. Example 2, we are evaluating the negative number. So how do you evaluate negative? This is positive. To evaluate the negative, it's just the same thing. Divide minus 5 by 3, but there is a little difference which you observe here. If you divide minus 5 by 3, you are going to actually get minus 1 point something. That's minus 1.6666 and all that. So all you need to do is take this up to minus 2. So when I take it to minus 2, and then that will give me the value I will multiply to. So whatever you divide, once it's negative, if you divide whatever you get, take it up to the next number you have, and then multiply it by that device or the mod, and then look for the number you will add to now get what you were originally given. So here, if I take this to negative 2, I multiply by the mod, which is 3, and that will give me minus 6. And so I'll now ask myself, what will I add to minus 6 to get minus 5? The reason we are doing this is that your mod must be positive. It can't be negative. So you can't divide this and say you are getting minus 1 and the remainder is minus 2. No, it has to be positive. And so if I add 1 to minus 6, I will definitely get minus 5. And that gives us our solution as positive 1, which is the remainder here. And so if we do that again for this example B here, you divide minus 52 by 11. Of course, you're going to get minus 4 point something. So take it up to minus 5, multiply by 11. That will give you minus 55. And when you add 3 to it, you will get your minus 52. And therefore, your solution is positive 3. And that's how to evaluate both positive and negative integers. Alright, so we look at how to do basic operations under modular arithmetics. We are beginning with addition and subtraction. So once you get into basic operations, all you need to do is do your normal operation and then change whatever you get into the mod you are given. So like here now, I have 9 plus 14. So all I need to do is add them normally like I am doing my normal base 10 addition, and this is going to give me 23. And then I will now change 23 to the least value in mod 7. And so by dividing this by 7, I'll get 3 remainder 2. Therefore, the solution of this is 2 mod 7. That is the sum of this 9 and 47. And then we go to the next example. This one is now in tabular form. They are asking us to copy and complete the addition table below in mod 5. Okay, so all you need to note is that you first of all pick the vertical value before adding it to the horizontal. If it's subtraction, the same thing. So if I pick this 0, I'll add it to this 0. Of course, it is 0. This plus everything here will be the same. Of course, it's still below 5, so it won't change. And here, up to this point, they have given to us. Look at where we are asked to do. Now, 1 plus 3 is actually 4. And so I'll write 4. It's not up to 5, so there will not be any. The remainder is just 4 itself. Now 1 plus 4 is 5. If I divide by 5, I'll get 1 remainder 0. So my answer here is 0. Look at this. 2 plus 1 is 2. Sorry, 2 plus 1 is 3. Okay, so here will be 3. 2 plus 3 will be 5. Divide by 5, you have 0. Sorry, remainder 0. 2 plus 4 is 6. Divide by 5, you have remainder 1. I will allow you to complete this other two. Of course, sorry, these other remaining spaces. Now, the next one here is subtraction. It says we should copy and complete the table in mod 5. So the subtraction is done in mod 5. Please take note. And then 0 plus 0, 0 minus 0 is 0. Of course, 0 minus 1 is going to give us minus 1. So can we now write minus 1 in mod 4? Remember, in subtraction, another way to actually change negative values to subtraction is by adding the mod to the value you have until you get a positive value. Like the one we did last, we said change minus 5 to mod 3. That's under example 2a. Okay, so what did I do here? Instead of doing that division, you can actually say minus 5 plus 3, and that will give you minus 2. And now you will keep adding until you get, this will give minus 2. You keep adding until you get a positive value. So I'll add 3 to minus 2 again, and that will give me positive 1. That's why we got 1 there. So, but the reason we use that division is that it makes it faster. So in this case now, I am going to use addition. So if I say minus 1 plus 4, I am going to get positive 3. And that's the solution here. 0 minus 2 is minus 2. If I add 4 to it, I will get positive 2. Now 0 minus 3 is minus 3. I will add 4. I will get 1. And so here 1 minus 3 is minus 2. So I'll get 2. 2 minus 2 is 0. So I'll write 0. 2 minus 3 is minus 1. If I add 4, I'll get 3. And then I will allow you to fill up these other 3 spaces. So that's how to handle subtraction. Now, what about multiplication? The same process. Multiply out whatever you get. You will now take it to the mod you are asked to do. So here we are asked to complete this table in mod 6. So remember what I said, that you will always start from the vertical and then go to the horizontal. So 2 times 2 here is 4. Of course, 4 in mod 6 is still 4. 2 times 3 is 6. 6 in mod 6 is going to be 0. Sorry, you get 1, remainder 0. 2 times 4 is 8. Remainder 2 if you divide by 6. This is 10. Divide by 6, remainder 4. We come over here. 2 times this is 6, remainder 0. This is 15. You have remainder 3. And then let me do this last one. I will allow you to fill this one. 5 times 2 is 10, and so remainder of 4. Of course, we can actually do this fast. This will be remainder 2. This will be remainder 3. Sorry, remainder 0, because this will be 12. This is 16 divided by 6, remainder 4. This is 20 divided by 6, remainder 2. And that's the complete solution here. So we go to the next example, and which is under division. Now, how do we divide in modulo? Now, this one is a little bit technical, but you have to observe very carefully. Look at what you have to do. First of all, we're asked to, evaluate this in modulo 11. First of all, give it a name. And so you say that your 29 divided by 3 is equal to x. And so you are looking for the value of x. And then when you get that x, you now express it in modulo 11. So what do you do here? I am going to now multiply this. And if I cross multiply, we are going to now get, we are now going to get 3x equal to 29. That's how we got this. Of course, this is over 1. If you cross multiply, you will get this. And now, since this 29 is in mod 11, what you need to do now to get your solution is you would have to take this to a value that is divisible by 3. Of course, 3 can't divide this without a remainder. So what am I going to do? Now, recall that if I have, for instance, 3 in mod 5, now, any value I add, if I add 5 to this 3, now whatever I will get will still be in mod 5. For instance, if I have 8 mod 5, of course, this is still equal to this. If you reduce this to the lowest term, you will still get 3. If I add 5 again to this, I'm going to get 13. If you reduce 13 in mod 5, you still get back 3. So if you keep adding 5 to whatever you have here, you will still be getting a value that will ultimately be equal to 3 in mod 5. So what am I going to do here? I am just going to be adding my mod here to this value until I get something that is divisible by 3. And so if I add the first time 11 plus this will give me 40. Of course, 3 can divide 40, but if I add again, I will get 51, and 3 can divide 51. And once you divide it, your value here becomes your solution. And so, although this is not the end here, because we can actually write 17 in a lesser mod in 11. Of course, if you divide 17 by 11, that's now going to give you 1 remainder 6. So it's actually equal to 6 in mod 11. And that is our solution. Okay, so we go to the next example. Here we have 65 over 5 in mod 4. So I equated it to y. It's not a must you will use x. And then when I now solved, of course, if you cross multiply, you have 5y equal to 65. And then, of course, this can divide. So there's no need to add anything. And so if it divides, you have 13 in mod 4. And of course, you can reduce that to give you 4 divide this is going to give you 12, 3 remainder 1. So your solution here is actually 1 mod 4. All right. And that's how to handle division. And finally, we look at how to solve equations in modular arithmetics. Look at this. And so we have simple equations here. So just like I said, under basic operations, just solve your normal equation the way you solve simple equations. And whatever you now get as your solution, you will now express it in the mod you are given. Okay, so what do I do here? I will just solve for x by taking 8 to this side, and I'll get minus 8. So all I need to do now is to express minus 8 in mod 9. And when I do that by adding 9 to this, I will get positive 1. And that's my solution. The second example, I'll make y the subject, and that's going to give me 5. And if you express 5 in mod 7, it's already the lowest. It's already lower than 7, so there is no point dividing. And so look at the next example. Solve the following equation. This one now are actually a little bit more complex than this. So what do we do here? The same thing. Look for your x. And in this case, I can't divide. If I divide here, it's not going to give me a whole number. So just like what we did under division, you will just start adding the mod until you get something that the coefficient here can divide. So if I add 7 once, I'm going to get 10, and 2 can divide 10. And so I will have that my x is equal to 5 mod 7, not 8, please. This is a mistake. And then example 2, I'm going to take this to this side, and that's going to give me minus 35. When you divide by 5, you will get minus 7. And when you change minus 7 to mod 6 by adding 6, you are going to get minus 1. You add 6 again, and that will now give you 5, which is our solution. And then finally, so you recall that we stated that we're going to see how to evaluate given integers in different modular, and I hope that has been gotten. And we also saw how to carry out basic operations in modular arithmetics, how to solve equations involving modular arithmetics. And that's where we'll end it for this class. If you have any question, you can always let us know. Bye.